All right, so let's do a question that has to do with tangent line and normal line. So it wants us to find those two lines at the point 1, comma 2. So right here. So honestly, you can draw both of these lines before you even do any calculus. I'll tell you that right now. And what you can do is you can draw these lines and then make sure the answers you get for your lines after you do calculus, make sure they make sense. So for example, without any calculus computation, I know that the tangent line at this point looks like this. Or close to it, right? The tangent line hits at the point exactly once, and then it kind of skims the curve. This looks kind of bad. Let me do this. It's gonna look kind of like that. Okay, that looks a little bit better. So that's our tangent. And then the normal line is perpendicular to the tangent line. So what does perpendicular mean? That means that the two lines, when they intersect, they create a 90-degree angle. So the normal line is going to be something like that. Because these create a 90-degree angle. So it looks like our tangent line is going to have a positive slope and potentially like a negative intercept. Potentially, I don't know yet. I just sketched this, randomly. Not randomly, but you know what I mean. And the normal line is going to have, well, presumably a positive intercept and a negative slope. So we can kind of know what our answer should look like. So now let's actually do the calculus to figure out what the equations of these lines are. So the tangent line. So tangent is basically synonymous with derivative in this case, because dy dx, or f prime of x, whatever you want to call it, this gives us the slope of the tangent line. Those are two directly related concepts, the derivative and the slope of the tangent line. Okay, so step one is to get the derivative. Okay, so f prime, we just need power rule here, which is really nice. So that's 6x minus 3x squared. Now, you're probably like, Meg, that does not look like a slope, right? When we think of a slope, we're picturing a number. Well, this gives me the equation to find the slope of the tangent line at a given x value. So if I want to find the slope of a tangent line of any point on this curve, all I need to do is plug the x value into the derivative. So we're concerned with the point 1, comma 2. Remember, this is x, comma y. So what x value do I need to plug into my derivative to figure out the tangent line? Well, 1. So I do f prime of 1, which is 6 times 1 minus 3 times 1 squared, which is 3. Okay, so now my slope of my tangent line is equal to 3. Does that make sense? I say it would make sense because that's a positive value and it's pretty big, a pretty steep number. Okay? And right away, we know what the slope of our normal line is because these two lines are perpendicular. So that means they have negative reciprocal slopes. So what do I mean by that? M normal, slope of the normal line, is going to be -1 divided by the slope of our tangent line. So what's the slope of my normal line? -1/3. Does that make sense? I think so, because look, line that I drew has a negative slope, and this line is it's not as steep. So that makes sense. All right, well now let's write the equation for the lines. So I found the slope, but now I need to do point slope form. So let's do the tangent line. So that's going to be y minus y1 equals m tangent x minus x1. So that's going to be y minus 2 equals 3 x minus 1. Remember, a slope of a line is y equals mx plus b, so let's write it like that. So we'll have what? Y minus 2 equals 3x minus 3. Add the 2 over y is equal to, y is equal to 3x minus 1. Does that make sense? I think it does. That means I did pretty good on my tangent line. Let me erase this though. Okay, so it intercepts at 1 and has a slope of positive 3, so up 1, 2, 3 over 1. Beautiful, up 1, 2, 3 over 1. Honestly, guys, I did pretty good. Oh god, that's so ugly. That's still kind of bad, but you can imagine that, right? Okay, cool. My normal line. Y minus y1 equals m normal. X minus x1. So I have y minus 2 because that's the point we're given. Negative 1/3 x minus 1. So what? Y minus 2 equals negative 1/3 x plus 1/3. Add the 2 over, that's what, 7/3? Okay. 7/3 is between 2 and 3, right? 7/3 is like 2.33. So like that makes sense. We did pretty good there. And then a slope of negative 1/3 down 1 over 3, what? Hang on. Down 1 over 3. Okay, I did pretty good, guys. My lines are pretty good. So my point here that I'm trying to make is you can draw the two lines first before you even calculate them. If that doesn't make sense to you, that's fine. But then how are you going to check? How are you going to check your answer? But yeah, there you go. Just make sure you take your derivative, plug the x value in, and then don't forget your point slope form. And then you're golden. All right, that's all I got.